In this video, we're going to talk about the different loops, which are nothing more than repetition, cycles. There's a while loop, a do while loop, and a for loop. Each one has its pluses and minuses. So we're going to do a simple while loop right now just to print out the numbers from, say, 1 to 10. So let's create a integer, and we'll call it number. Remember, you always want to initialize it. And I'll create just something as a constant, and we'll call it largest. And we'll make that 10. And the reason for the red squiggly line is because we declared constant, but we did not actually say. All right, so the first thing we're going to do is do a while loop. So we're going to test a condition. While number is less than or equal to 10, or actually largest, we're going to do this. And then we're going to add something to it to make it a little bit more flexible for us to change. We're just going to do cout number and we'll do an endl. If we did this right now, this would constantly do that. So yeah, we want to do 1 to 10. So we do want to put the equal sign in here. But that's also why you want to do one thing and test it. So let's leave this equal sign out. We want to print the numbers from 1 to 10. So right off the bat, it's going to print out 0 to 10. So let's do this here. And then we'll make an adjustment. Let's just do number equals 1. And so while number is less than largest, print out number. Now, if I were to do this right now, it would go on and on and on and on and on, because right now we're not incrementing number. So what I'm going to do here is do number plus plus. Oops, let's try plus plus. And we'll do this here. So let's go and run it and see what happens. And I just need my return statement. And let's run it. And if we did this right, it should print out 1 through 10. But we know it's not going to print out 1 through 10. So then we're testing something that we know what the result should be right away, very easy to determine. And that tells us if we have a logic error. So let's go and see what happens. And it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know right off the bat something's wrong. So what is it wrong? Oh, we didn't get 10. So that's where you need the equal sign. So what I'm going to recommend doing is do the smallest and then the largest in there. You could call it something different in here. So let's run it this way again. So here we're going to set the number to smallest. And then we're going to do something that I prefer you don't do, but we're going to do it anyway. So let's go and click on this and see what happens. So now we have number from 1 to 10. So let's just make a simple change. I want to make it 15. So see how easy it is? I don't have to change anything here. I don't have to change anything here. I'm going to go. Now, if I did it right, it's going to print out to 15. So now what I want to do is I want to demonstrate the plus plus in here and why I don't want you to do this. And it's going to be the same thing here, but I'm going to put plus plus here. So let's go and run it again. And look at that, it presents the same results. Okay, let's go now and put the minus minus here. The plus plus here. And let's see what we get. So now look at this. We wanted to go from 1 to 15, but now we're going from 2 to 6. The reason for that is at this point in time, number is 1. What we're doing is we're incrementing the number before we're actually printing it out. But the reason why it's not good programming to do this, although it's perfectly legal, it's easy to make a mistake. And then you're also, technically, you're doing a calculation inside of a cout, which I discourage doing it. I rarely do them unless it's absolutely necessary. And there are times when you're trying to print something, and you'll see that when we start doing arrays. So now we have the same thing over here. Let's do something different. Let's print out the square of the numbers from 1 to 10. And so what we need now is we need another integer. And we'll call it square. So now what we need to do is before we print out the number, we need to get the square of the number. So there's two different ways to do it. You can do square. Since we're just doing square, you could do this. Or a better way, and when you're squaring integers, it's really easy. But if you're squaring, if you're cubing, if you're doing something, you don't want to have to go number times number times number times number. So if you include CMath, then you could do POW number, comma 2. So this is a better way of doing it because then it's so much easier to make any changes. But for square, let's do it here, and then we'll change it to the power, and let's see if we have anything different. So now we should get 1, 4, 9, 16, and so on. So let's see what we got in here. We're not printing it out, so we're going to print out we'll put a couple of spaces. We're not really worried too much about formatting just yet. You can always format after you get the results proper. And then we'll do square. And let's go and print it, and let's see what happens. So we should get 1 to 100. And nothing's happening. All right. So we have 1, 4, 9, 16, 30 square. And so notice this is not formatted, so it's not that big a deal in there. So let's go and we'll make one other change. Let's make this square equals and then oops, don't need is. So the reason why we're getting a nasty message here is because we don't have a semicolon. And we're getting this. Now, notice that POW is not giving us an error, but it may in certain versions of Visual Studio. So you want to include CMAC just to be on the same side in there. So let's go and run it again and see if we get the same results. So that looks good. Now they say, well, we don't want to do the square. We want to do the cube. All you have to do here then is change this to a 3. And they go, no, we want to do it to the 4th power. Just change it to 4. No, we want to do it to the 5th power. Just change it to 5. So now we should get 1, 8, that I think 27 would be next, and 64. So let's see what we get here. So we have 1, 8, 27, 64, 125. So that looks good. So that takes care of this right now. So we're good to go. And